Hello, folks. Thanks for joining us today for our Safety and Health magazine webcast. We were going to give our audience just a minute to settle in today, and we will start the presentation shortly. Thank you. Once again, we appreciate you joining us today. We're going to give our audience a minute just to settle in here, and we'll start the presentation shortly. Thank you. Well, a formal hello to everyone, and welcome to today's Safety and Health magazine webcast, Simplifying OSHA Rooftop Fall Protection Requirements, sponsored by Kee Safety. My name is Barry Botino. I'm an associate editor at Safety and Health and a co host of our On the Safe Side podcast. I'll be the moderator for today's event. Before we get started, I want to share a few housekeeping items. First, the views of today's speaker and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the Council or the magazine endorses those items. After today's event, we'll conduct a Q&A session with our speaker. If you have a question at any time today, just click the Q&A button located at the bottom of your screen, type in your question, and tap the send button. After this presentation, you'll also be asked to complete a brief evaluation survey, but I'll tell you more about that a little later. Finally, this webcast will be archived. If you want to view this presentation or any of our past webcasts, please visit us online at safetyandhealthmagazine.com/events. You may also receive a link in our post-event email. Now let's introduce our speaker. Joining us today is Daniel Huntington. Daniel serves as general manager at Kee Safety and is an experienced sales and product trainer who has spent more than a decade in the fall protection industry. He is formally trained in the OSHA Fall Protection Standards and Risk Assessment. As a respected compliance educator, Daniel presents at various events, including the annual American Society of Safety Professionals and Western States Roofing Contractors Association Expos. With that, welcome, Daniel, and please take it away.
Thank you, Barry, for that awesome introduction. And thank you, NSC, for hosting us and this webinar. And thank every single one of you for giving me an hour of your time today to learn about a topic that I'm personally very passionate about, excited to share with all of you. And I'm really looking forward to it. So thank you, guys. And thank you once again, Barry. So what are we going to talk about today? Well, like Barry said, I've been in this industry for a little bit over 10 years. I don't want to tell you how many years over 10 I've been doing this, but in that time, walking on roofs, assessing hazards, providing solutions, I started to notice a pattern, the same hazards coming up over and over and over again. And so I kept having the same conversations over and over and over again. So what we did is we took kind of that 10 years of experience in the field, answering frequently asked questions. We've distilled it down into about an hour, hopefully a little bit less to leave time for questions to share with you guys. So again, thank you for your time. Before we dive into the content, I'm going to make you guys 3 promises today. Promise number 1 is that I'm going to be as engaging as I possibly can be, given the medium that this presentation is being done on. It's hard to stay engaged on a webinar. I know, because I join and I watch webinars. Your phone's ringing, your email's dinging, people are knocking on your door. So I want to share information with you that I believe is life-saving, that I believe is applicable. And I'm going to try and be sharing that information in a way that's engaging enough to keep your attention. So I promise to be engaging. I promise to keep it applicable. So we're not going to talk in theories or like kind of pie in the sky ideas. This is in the field, applicable knowledge. Think about your facility while we're going through it and how to apply this knowledge. I can guarantee you, you can take at least one action item, if not more, from this presentation at the end of this hour that will end up in keeping people safe and separating people from hazards, specifically fall hazards. And promise number 3, this will not be a sales pitch. I'm here to educate, provide education. It's what I'm the most passionate about in our role. Yes, we do manufacture these solutions to these hazards, and we'll touch on them very briefly as examples of how to protect people from the hazard. But the core goal is education. I want to provide education because at the end of the day, I have a core belief that everyone feels the way that I do. Everyone deserves to go home safely at the end of the day. If we can control somebody from being injured by a potential hazard in the workforce, we want to put those controls in place. We just don't know what the best thing to do is. We don't know how to assess those all the time. So that's what I'm trying to bring. All right. So all that being said, let's get down to business today. So like I said, I've been doing this for slightly over 10 years. And I noticed I kept coming across the same 3 hazards on every commercial roof that I walked on. And it didn't matter if I was at a hospital, a manufacturing plant, distribution center, the oil and gas industry, every single hazard came down to the same 3. So we're going to talk about those 3 hazards. We're going to do it in a structured way. We're going to introduce the hazard. We're going to break down the OSHA code that hazard that applies to that hazard. We're going to dig into any nuances in the code that we have to understand. And I would say put context around it, and then answer any frequently asked questions on those hazards. So that's the structure that we're going to kind of go through. But there's a bigger kind of meta context that I want you guys to pay attention to as well, which is the idea of rooftop fall protection is very complicated because your facilities, for the most part, are very large and complicated. And so the idea is always, I don't know where to start. That's always like the first hurdle that we have to overcome. So I'm going to present the hazards in the order in which I train that they should be protected, and I'll explain why I put them in that order. So your first takeaway from today can be, I don't really know where to start, but now I have an idea of one thing that I can do to improve safety that will actually make an impact on my facility. So pay attention to the order in which I present the solutions and the justification why I'm putting it in that order, because everything has to tie back to the federal OSHA code and to logic, right? We want to make sure that what we're saying makes sense. Okay, so let's dive into the content. I want to set the stage first. So, we have several hundred people joining us, so I don't know your exact situation. So to set the stage, very commonly, I'm called in, and I'm going to meet with a facilities manager, a safety manager, sometimes a site engineer, sometimes a plant manager, or even like the GM of a plant. We're going to sit down in a conference room, kind of like I'm sitting in right now. And you're going to start telling me about your concerns when it comes to rooftop fall protection. So that's the stage I want to set. We're sitting in a conference room. We're talking about your facility. Your concern, 9 times out of 10, you're going to say, hey, we've got workers. They're going up on the roof. We don't have any protection. We've got units near the roof edge. We're worried about them falling off the edge of the building. What can we do to protect the edge? All right, absolutely. Let's understand kind of what the work is, the frequency of the work, how long it takes to do. But before we get there, my first question in every meeting is, how are we getting onto the roof? What do our access points look like on that roof? Now, I'm going to explain why I put this as our first hazard on the next slide. But first, let's just break down the OSHA code. Very quick 20-second education on OSHA. So OSHA stands for the Occupational Safety and Health Act or Administration. depending if you're talking about the law or the governing body. OSHA has two basic sets of books. We've got the construction code, which applies to the workers that built the building. Then we have the general industry code, which applies to the workers maintaining the building. What we're talking about today, the code that's on screen right now, is the general industry code. So this applies to any workers servicing equipment, cleaning the roof, responding to leaks, right? This does not apply when the building is being built. Think about it in the lifespan of the building. Let's say a building takes a year and a half to build and it stands for 80, 90 to 100 years. We're talking about the 99% of the lifespan. This code applies to it. That code is OSHA 1910. If your code that you're referencing starts with 1926, that's a construction code, which would not apply to building maintenance workers. Next, we have .28. So the .28 standard is the fall protection standard. Back prior to January 2016, this used to be .23 was the fall protection standard. That was the original fall protection code, and it was updated in January 2016. And so if you see an OSHA code that is maybe in your safety plans or that somebody's presenting to you that's referencing a 1910.23 plan, it's an outdated code, or they're referencing to ladder safety, which is the new 1910.23. I don't know why OSHA didn't retire the jersey number, but that's where we're at. Then we have these numerics, B34. So B34 is the sentence within the code, right? So the OSHA, the Occupational Safety and Health Act, it's a law. And then we have sentence references. So we can go in, you guys can go Google this and independently check to make sure that what I'm putting in front of you is accurate. But this is the code that we would look at to understand how to protect workers accessing roofs through access points. So let's break down the code itself. The code states that each employee must be protected from falling into a ladderway floor hole, okay, or a ladderway platform hole by guardrail system and toe boards erected on all exposed sides except at the entrance to the hole, or a self-closing gate or an offset must be used. So we have two terms in this code that we have to understand. I always say, OSHA, it's a law. It was written by lawyers for lawyers. So they use terms that we don't use very frequently, right? I've never said, hey, climb up the ladderway floor hole and I'll meet you on the roof. So what does that mean? Well, a ladderway floor hole, in this instance, the roof is our walking working surface. So we're standing on it. So the roof is the floor. And the ladder is coming up through a hole in the floor. So you and I would refer to this as a roof hatch. So it says that each employee must be protected from falling into a roof hatch or a ladderway platform hole. In this instance, the roof is a platform that I'm stepping onto and off of to get my work done. And the roof is a platform, right? And so we would call that a fixed ladder on the side of the building. So it's saying that we need to protect employees from falling into a roof hatch or off either side of a ladder with a guardrail on either side of the opening, except where I have to climb through, where I have to put a self-closing gate or an offset. Offset's easy to understand. Sometimes we'll use the term cattle chute to shoot people into the middle of the roof. You can use guardrail to make a turn in the guardrail. So if you don't want a gate there that's, maybe could pinch somebody's fingers or something like that, which properly designed gates won't. I'll talk about that in a minute. But the term self-closing is actually kind of really important because they used to use the term swing gates before they updated the code. And that led to a lot of interpretation regarding chains that I'll cover in our frequently asked questions portion of this hazard. So the OSHA code, we understand it. This is as simple as it gets for OSHA. We don't have any choices. If we have a hatch or a fixed ladder that are up on a floor or a platform, it doesn't have to be just a roof, we have to protect it. There has to be a self-closing gate with guardrail on either sides. But I need to justify the reasoning why I rate this hazard so highly. Why do I believe that this is one of the most important hazards that we protect? And why is it often the most overlooked hazard on any roof? To understand that, we have to break down how do we say one risk is more critical than any other risk, right? So to do that, we use the tool called the risk assessment matrix, which everyone in the safety industry is very familiar with. If you're not familiar with it, the way that it works is that you rank the potential severity of an accident, should it occur, from 1 to 5, 5 being the worst, and you multiply that number times the likelihood of the accident occurring ranked from 1 to 5. Meaning, if it's an injury, should it occur, could be debilitating or fatal, we would give it a 5. And if we're almost certain the hazard's going to happen, we'd rate that a 5, which would give us a risk rating of 25. The most critical risk, we need to address it immediately. So let's take this concept and apply it to fall protection. So in the world of fall protection, every potential fall is a 5. The way that I explain this, the minimum height requirement for fall protection in general industry is 4 feet. In construction, it's 6 feet. So any work being done 4 feet or higher needs some form of fall protection. Look at your desk. Don't actually do it, but look at your desk. And let's say it's about 4 feet tall. And let's say you're about 6 feet tall. So stand on your desk. Don't really stand on your desk, but in your mind, stand on your desk. Your head is 10 feet above the ground and you fall backwards and land on your head. That is a potentially debilitating injury at the lowest threshold at which fall protection is required. Apply it to rooftop fall protection, and we're exponentially higher. Falls occur at 32 feet per second squared. So what that means, if I were to fall or trip backwards off of a 90-foot tall building, that fall is done in under 3 seconds. I do not have time to react, to pivot my body, to land on my feet or tuck and roll. So we're always at a 5. Likelihood is the term that people get caught up on because we use it's a subjective term, right? When I meet in a facility, we're having this conversation, the way you can kind of spot people trying to think through the likelihood of a fall occurring is they start to use kind of subjective language, right? Like, well, no one's ever fallen before. Okay, yeah, that's means something, but it doesn't guarantee that nobody can, because that's not how accidents work. Or they'll say, knock on wood, our guys are pretty careful. Well, that's the feeling of careful is very subjective. I've had people tell me, I'm not going to fall because I'm not afraid of heights. So I'm real sure-footed. I'm like, yeah, that's not how gravity works. Gravity doesn't care if you're, real sure-footed or not. An accident can happen to anybody. So what I like to do is let's get rid of the term likelihood. Let's look for an objective measure that we can start to look at where we can start to predict the likelihood of an accident occurring. The best predictor of likelihood is frequency of exposure to the hazard. So what that means is that we can start to measure the frequency or the exposure count to hazards. And then we can start to rank, okay, well, if we're exposed to this hazard more frequently, we have a higher likelihood of an accident occurring. Therefore, we need to prioritize protecting this hazard. And it gives us a really clear and measurable way to start tackling the complicated world of rooftop fall protection. So the example I always use is our swimming, right? You're more likely statistically to drown in a pool than in the ocean. It doesn't mean that pools are safer than the ocean inherently. It means that we swim in pools more often than we swim in the ocean, right? So it's just frequency of exposure. So let's take this idea, let's apply it to a roof. So take this concept, apply it to a roof. So in this example, on separate occasions, our primary access point is through this hatch right here. Twice a year, we've got to service this hood unit up here. We've got belts that need to be changed. We got a motor that needs to be maintenance. So we're there twice a year. One time a year, we've got to reseal these skylights. Skylights tend to leak. UV degradation is kind of a problem. The caulk tends to dry out. So once a year, we're resealing a skylight. 4 times a year, I'm right on this edge with this HVAC unit. I've got filters that need to be exchanged. I've got PMs. I've got motors. So I'm there about 4 times a year. Spring and fall, I'm out. I've got leaves, or I've got cottonwood that I'm cleaning out in the spring and fall. So I'm cleaning out these drains on this edge twice a year. Question is, which hazard are workers exposed to most frequently? Just by frequency. Let's count them up. Well, obvious answer is the edge, right? Because I'm on this edge 4 times. I'm on this edge 2 times. So I'm combined 6 times a year on that edge, right? Well, not so fast, because every time I come to the roof, I'm passing through the access point. I have to hit this access point. So I'm going to hit that 2 times, plus 1 is 3 times, plus 4 is 7 times, plus 2, 9 times, right? I'm going to see this access point 9 times a year, right? Wrong, because I also have to come back down through my access point. So I have an 18x exposure count in this example to this access point, to this hazard. So I have an exponentially higher exposure count to the access point than anywhere else on the roof. Now, I'm not saying all we have to do is protect the access point, because there's 2 factors. There's exposure and time of exposure. So we have count and time. But by just the exposure count, access points are by far our most frequent hazard on the roof. And anecdotally, in my experience over the last 10-ish years, we see access points unprotected every day, every roof. We have hatches and ladders that don't have the adequate protection around them. The questions that I get asked around access points are, number 1, can I use a chain instead of a self-closing gate? Answer is, you used to be able to, but not anymore. In the old code, if you remember, I said earlier, they didn't describe the gate as a self-closing gate. OSHA described the gate as a swing gate. And what that meant is, in the mid-'80s, a letter of interpretation was sent to OSHA saying, hey, can we use chains instead of ladders, instead of gates at the top of ladders? And OSHA came back and said, yes, as long as they provide protection at least as effective as a swing gate. New code comes out 40 years later, and they say, now you need to use a self-closing gate. And in the Federal Register, there's a document that OSHA published where they documented and justified every change. And that one word has probably 5 or 6 paragraphs of justification on it, which is where we pull this text from. And it states that OSHA does not believe that chains provide protection at least as effective as self-closing gates. And for that reason, they're not allowing chains instead of self-closing gates for 2 reasons. Number 1, nobody put the chains back, right? So you just have these chains just dangling there doing nothing. But number 2, as I'm climbing down, so I'm on the side of the building, the side of the silo, work platform, whatever it is, hanging on the side of the building, trying to maintain 3 points of contact, I'm required to reach over, grab a chain, reach above my head, and reattach it. That's kind of dangerous to do that. I need to be focused on climbing and maintaining 3 points of contact. And so they said, it's a dangerous act to reattach the chain. So we're not allowing you to use those anymore. No grandfather clause, no exemptions, just this is the law. The other question that I get a lot is regarding when vertical climbing devices are required and when a cage is required. This was a change now in the 1910.23 code, which is now the ladder safety code, but is also in 1910.28, talks about vertical climbing devices. So cages are no longer considered fall protection. You can just They're not banned as long as they don't interfere with you climbing, but they're not seen as fall protection. They actually don't stop you from falling because falls happen vertically. You know, when you fall off a ladder, it's because you missed a rung, you dropped, and your grip strength isn't strong enough to hold your weight jerking this far. Technically, with both hands, you are able to hang on statistically with both. That's why it's important to maintain 3 points of contact, because if you only have one hand here and your foot falls, you are not strong enough. The average person is not strong enough to take that jerk without letting go. So you fall straight down. So the cage isn't going to help you. It's just going to mangle you up as you kind of flail and fall. So vertical climbing devices, which come as a cable, SRL on a dabbing arm up above you, maybe it's a rail that you're tied off to, are required on any ladders 24 feet or higher. So any ladders 24 feet or more, I need to be tied off to it. The cage isn't banned, but it's just not helpful, not needed. So you can have it or not have it. I prefer not having them personally because I'm always carrying equipment like a backpack that tends to get snagged, and there's nothing worse than getting kind of jerked back while you're trying to climb a ladder. But those are the questions that I get. There's a lot of confusion about when we have to abide by this law. So basically, after November 2018, every new ladder needs to have a vertical climbing device if it's installed over 24 feet. Any major repair to a ladder needs to be equipped with a vertical climbing device after November 2018. And every single ladder in America over 24 feet tall has to be retrofitted with a vertical climbing device by November of 2036. So set your calendars. We have 11 years and counting. It sounds way off, but it'll go quick, trust me. So those are the questions I get asked about access points all the time. The way that we protect access points, we put guardrails around the hatches. I like to integrate grab bars that we can integrate into the opening so I have something to grab onto when I climb up and down. We mount these to the drip edge to not poke any holes in the roof while maintaining OSHA compliance. Or we do non-penetrating guardrail at either side of a self-closed or either side of a ladder with a self-closing gate integrated into it. What we do is you mount the gate to the railing. You don't mount the gate to the ladder. There's nothing more frustrating than climbing a ladder and at the top of that ladder is a gate about to hit me in the face. It has to be mounted to the railing, so there's room for me to transition my body onto the roof and just walk through the opening. My body should push open the gate. I shouldn't have to touch a gate with my hands at all. It closes behind me. I don't have to wrestle with it. It's not pinching my fingers. That is a properly designed access point at the top of a fixed ladder as compared to just a gate clamped to the top of the ladder. If you've ever dealt with it, you know exactly what I'm talking about. It's so, it's dangerous, honestly, but it's very frustrating. All right, so that's it for access points. We're at 30 minutes past the hour. That's the longest one, so I promise the rest of them won't take as long. I like to always take a 10-second pause. Think about your facility and think about how you're accessing it or how your employees are accessing it. Are the access points safe? And then take the next step to think about how are my roof-to-roof transitions? Because a lot of times, maybe I've got a stair tower to the roof or I have an internal penthouse to the roof that's safe, but then I have to go roof to roof to roof and I have unprotected fixed ladders along that way. And then think about your work platforms inside the facility. Do they have chains at the top of them? A lot of them probably have guardrails, but no gate. So think about those as well. And if you have a question that comes to mind, throw it in the Q&A. We'll try and get to it later on. Okay, so we've talked about access points. Let's talk about the next most hazardous portion of a roof, holes in your roof, also known as skylights. Statistically speaking, you're actually most likely to fall through a roof than off of a roof. There's a couple reasons for that. I think number one, I always call it my spidey sense. When I climb a lot of roofs. I hate being near the roof edge. I'm not comfortable with it. I know all the stats. I know what happens when you fall. I've talked to fall survivors. I've been part of fall cases legally. I'm very educated in this. I don't like the edge. So I don't go near the roof edge as much as I can avoid it. But anytime I'm near an edge, I feel it on the back of my neck, like, ooh, this is dangerous. Some facilities that you guys manage, 2-3 football fields wide, right? Sometimes we got to get in a golf cart to get from one end of the facility to the other. I'm on a roof, I'm 200 feet from any edge. I feel pretty secure up there. But what mentally I don't realize is that little opaque white dome next to me is the equivalent of a hole. I can't see through it. I don't register it subconsciously as a hazard. And so I don't treat it with the same caution that I treat the edge. There's also a lot of misconception that skylights are fall protection rated, which they're not. And we'll talk about that in the FAQ section. And then lastly, I'm coming to you guys from Buffalo, New York. We've been covered in snow since late November, early December. So any roof work being done, the skylights disappear. So you could step on a skylight and not even know it until it's too late. You've broken through the dome. But let's dive into the code. So the OSHA code that we're talking about is 1910.28, subpart B31. And it states that each employee is protected from falling through any hole. And in the code, it says including skylights. So I didn't put that in there. Google that code so you can read it yourself. It says that's 4 feet or more above a lower level. There's an instance of our minimum of 4 feet height requirement in general industry by one or more of the following options. So OSHA now gives us options. In the first code, they did it. Access points, guardrail, and a self-closing gate. That's our only choice. Now I have 4 to choose from. 2 are bad, 2 are good, 2 are bad, and I'll explain why. Option number 1 is a cover. You got a hole, put a cover over it. Makes sense to me. Typically, when we're talking about skylights, the covers are skylight screens. So we allow light to come through, but not people to fall through the opening. Or we can do a guardrail around it. So again, makes sense. You got a hole, put a railing around it. Nobody can fall into the hole. Makes total sense. Then we go into a travel restraints or a personal fall arrest system. So these may be new terms for you. I don't want to assume that everybody's gone through their OSHA competent person class, but if you were to go through your OSHA competent person fall protection course, what you would learn about are the ABCs of fall protection. So here's a non-accredited 30-second OSHA competent person class. ABCs of fall protection. A stands for your anchor. So it's what you're tying off to. It's an anchor point or horizontal lifeline on the roof. B stands for your body harness. So the thing that you're wearing that you're going to connect to the anchor on. And C is your connector, the lanyard that connects your body to the anchor, right? Those systems can be designed 2 different ways. I can design a system where my anchor is, let's say, 8 feet, or let's say 10 feet away from the edge, and I have an 8-foot long connector or lanyard. So that way my body can't get within 2 feet of the edge. I'm stopped, right? That's called a travel restraint system. I can run to the edge, but my rope's too short. It's like a dog leash. I can't fall over. Or I can design a system that's a personal fall arrest system. The key is in the name. You're going to fall. So my anchor's 8 feet from the edge, but I'm wearing a 10-foot lanyard. So 2 feet of my lanyard can go over the edge along with the rest of my body. Those systems rely on your deceleration of the fall based on the equipment that you're using, stopping your fall before you hit something on the way down. And there's some nuances in there. When you fall off the side of a building, you on average need about 12 to 15 feet of distance to fully decelerate safely, depending on the PPE that you're using, if it's a 36-inch or 48-inch tear-out lanyard. That's slowing down your fall. The issue with that is that maybe I'm 20 feet up in the air, leading edge to ground's 20 feet, so I have 5 feet of play. I'm safe, right? but there's also dynamic changes in my fall distance that I need to be aware of. If I'm working above a loading dock and the truck, there's an LTL, a box truck backed into the loading dock, I don't have 20 feet to fall. I have 7 feet to fall because I got 13 foot of trailer eating up that height. So personal fall arrest systems are actually very dangerous, and we haven't even gotten into the fall rescue. So the reason I don't think that we want to be using a personal fall arrest system when it comes to skylight fall protection is that we don't know what's underneath this skylight. All right, if I'm falling through the skylight, what am I going to hit below it? Racking. I could hit electrical conduits that a contractor just ran right underneath the skylight. I could hit the fire suppression system. I could hit a second floor. I could hit a mezzanine. I don't know what's below it. But before all of that, I need to break the dome with my body. What's going to happen to me, right? I'm going to fall through. I break the dome. I've got the shards of that skylight hitting me in the face and upper body. I'm probably going to get cut. So I'm all cut. What happens to the people below the skylight, right? They're looking up. All of a sudden, first thing that comes through is a bunch of shards from that dome falling down. So we have a struck by hazard on them. Plus, I'm cut. So we have biological contaminants coming down into that area below the skylight. And then potentially a person falling through and hitting them underneath that skylight. So there's a lot of hazards around skylights where personal fall arrest doesn't actually work. OSHA gives us the option, but OSHA is bare minimum fall protection, and we haven't eliminated all the hazards. Travel restraint is better because I can get to the hole but not fall into the hole. But in the practice, it's really hard to design, because when I have a travel restraint system along an edge, I need to maintain, 2 feet clearance away from any single edge. A skylight has 4 edges. So I have to maintain 2 feet of distance from 4 edges per skylight. And a lot of times we have 10, 20, 30, 80 skylights all in a row. So it's super difficult to design a travel restraint system around skylights. How do I walk past the hole without falling back into it? So that's why when it comes to skylights, covers, guardrails, they're the most effective options, even though OSHA gives us these other solutions. As far as frequently asked questions, number one question that I get is my skylight fall protection rated? The answer is it probably isn't. The reason it probably isn't fall protection rated is that skylights are made out of plastic. Most of them are not made out of glass or tempered glass. Some are, and there are some fall protection rated skylights. You can walk on some glass that's designed, over atriums and things like that. I wouldn't do it, but it is designed that way. But your typical dome skylight is made out of plastic, and that plastic breaks down and becomes brittle under UV degradation. One way to know if your skylight's fall rated or not is that it'll have a sticker that says danger, risk of fall. The only issue, as you can see in the photo I took in the field, is that sticker is made out of plastic. So that sticker burns up. So if you don't see the sticker and you don't see anything, it's probably because that's burned up and your skylight's becoming extremely brittle. The other question that I get is the bars underneath the skylights. Are those considered fall protection? If you don't know what I'm talking about, go to Walmart, go to Home Depot, look up. They have bars underneath the skylight. Those are called burglar bars. They're designed to keep people from grabbing a ladder, climb up on the roof, in the cover of night. You smash open the skylight, you Mission Impossible zip line down in, you get all the Samsungs out through the roof and you disappear. That's what those are designed to do. The reason they're not for fall protection is because they don't eliminate all the hazards. They don't eliminate me crashing through the dome. They don't eliminate the lacerations, biological contaminants, or the struck by hazard down below. So we have all those other hazards that we need to contend with, and they're probably not weight rated to 2 times intended load, which is what the OSHA requirement is for fall protection, according to OSHA 1910.29, which tells us what the testing requirement is. So bars under skylights, I see them a lot Really, again, retail is when you see them most often. But even in like high-end manufacturing plants, pharmaceutical, biopharmaceutical manufacturing plants, distribution centers, anything that we're moving materials that are worth something, you're gonna see those in there to protect people from stealing it. But again, it's not the design intention. How do we protect it? Number one, cover it. Put a screen over it. We use tension to fit a rail on either side of the skylight. You pop the screen into the rail. There's no screws. There's no holes drilled. There's no penetrations to cause any leaks to protect people from falling through. And if you need to, you can actually remove it to replace or repair the skylight and then put it back on, obviously, while you're properly tied off for that role or that job. Or we would do a non-penetrating guardrail around the opening of the skylight. We use corner weights. So these weights are kind of shaped like L's. They rest on the corner and box out that skylight. All right. So in the last 20 minutes of the call, should take about no more than 15. So if you have questions, throw them into the chat. We should have at least 5 to 10 minutes to answer your Q&A at the end. But we're going to dive into unprotected edges. Before I do that, I always like, again, to pause. Think about your facility. Do we have natural light in the facility? Are we utilizing skylights? I think they're great. I love using natural light, reducing carbon, reducing electricity usage. I think there's a lot of benefits to natural light. But if we're going to take the benefits, we need to do it safely and not have somebody risking their life near an open skylight, or what OSHA calls a hole on your roof. Okay, let's talk about unprotected edges. By far, the most frequent hazard that we protect. Most of our projects are sent out protecting the edge primarily, with everything else as auxiliary add-on, even though I think that it should be the other way around. The code that we're looking at is 1910.28 subpart B13. And the way that OSHA breaks this down is they give us 3 zones. So we're going to work from the edge, the outside edge, and work our way towards the middle of the roof. So every zone gets further away from the hazard, further away from the fall. So what that means is that we are going from the most critical area to the least critical area. So OSHA 1910.28 B13 states in part 1 that when work is performed less than 6 feet from the roof edge, the employer must ensure that each employee is protected from falling by use of guardrails, safety nets, travel restraint, or personal fall arrest systems. So what that means is, if I'm working in this area, I need to have some form of fall protection, whether it's guardrails, nets, anchor points, and restraint or arrest. OSHA doesn't care, but this is the most critical zone that we need to keep workers safe in. The reason that it's the most critical zone is we're 1 body length or closer from the roof edge. That's how I always think of these zones. So 6 feet is a body length away. We talk about slips, trips, and falls, and we talk about them as separate categories of hazards, but they're actually typically a series of events. I slip, then I trip, then I lose my balance, and I fall. Any slip or trip in this zone can prove fatal, right? If I'm standing at 6 feet, I step backwards, and I have an untied shoelace. I lose my balance, I take 2 steps towards the edge, my center of mass is off the edge in this zone. So the most innocuous mistake, a stub toe, an untied shoelace, I stepped on a rock, can prove to be fatal, which is why OSHA considers this to be the most critical zone when it comes to rooftop fall protection. And there's no ambiguity. If you're working in this area, you have to be protected by something, whether it's a guardrail, safety net, travel restraint, or personal fall arrest. That's really straightforward. Zone 2 gets a little bit more nuanced. We're 1 body length to 1.5 body lengths away from the roof edge. It states that when work is performed at least 6, but less than 15 feet from the roof edge. The employer must ensure that each employee is protected from falling by use of a guardrail, safety net, travel restraint, or personal fall rest. And it goes on to say that the employer may use a designated area when performing work that is both infrequent and temporary. So we have 3 new words that we need to learn. Number 1, designated area. What does that mean? A designated area, if you're looking 1910.29, that specifies the performance requirements of fall protection systems. A designated area is a warning light system. It is visible from 20 feet. It is at least 39 inches tall with sag no greater than 34 inches, using cable with tensile strength of at least 200 pounds. That's what it is. It's not a painted line. We'll get into that in a minute. So it's basically a warning line, a flag system I can use at 6 to 15 feet away. But I can only use it if the work is considered infrequent and temporary. Infrequent means that I'm on the roof less than once a month, according to federal OSHA, or less than once a quarter, according to Cal OSHA. And temporary, meaning the work takes 1 to 2 hours to complete in a single trip. So you go up, you turn the machine on and off again, and you're done. You don't go up, run a diagnostic, come back down, get your tools, go back up and fix it. That's not temporary. It's meant you go 1 hit through the access point, 1 hit to that area, and you're done. You have to be behind something, right? You have to either be tied off, have a guardrail, or have a warning line letting you know not to go closer to the edge than 6 feet, or wherever you end up putting that line. The third zone is 15 feet or greater away from the roof edge. In this area, it says that employees must protect each employer from falling by use of guardrails, nets, restraint systems, arrest systems, designated areas, or the employer is not required to provide any fall protection, provided that the work is infrequent and temporary, and we implement and enforce a work rule prohibiting employees from going within 15 feet of the roof edge. So it's not good enough. The key word here is enforce, implement and enforce. So it's not good enough to just say, hey guys, you have a 15-foot rule, so be careful up there. And you got a bunch of units within 15 foot of the roof edge that they have to go to work on. Oh, well, we told you not to do it. Well, it's impossible for me to do my job while doing that work rule. That's an unenforceable work rule. Ways that we like to enforce this rule or help employers enforce the rule. Most popular way, the training is, guys, there's 7 units on our roof that are within 15 feet of the edge. Each of them have a corral or guardrail around them. You're required to go in from the back of the corral, do your work, come out of the corral, which will deposit you 15 feet away from the edge. You travel to your next destination. You go in the corral, you come back out. We don't just put guardrail along the edge because you could just go from one and then just walk straight to the next one. So we're not enforcing that. Another option, guys, we have a warning light system at 15 feet. We have temporary anchor points inside the warning line. You tie off, you set up your anchor point across from wherever you need to go and do your work. You tie off to it, you go below the line, you do your work, and you come right back. Another way, we have a horizontal lifeline or anchor points set at 15 feet back. You walk behind the anchor points. If you have to cross them, you tie off to them, you go do your work, you come back, right? That's what an enforceable work rule looks like. It's not, hey, be careful up there, guys, 15 foot, remember, right? That's not how that works. Little graphic that we created shows you the closer that we get to the edge, the higher our risk rating is. So if we take that and apply it to our risk assessment matrix that we had before, it looks like this. The closer we are to the edge, the more likely a fall we have of a fall occurring, the more critical it is that we protect that area. So therefore, that's how we rank it. So we want to look at your access points, holes in the roof, and then we look at the edge starting from the outside, working our way in to kind of break down the process. Frequently asked questions. Number 1, what's the difference between temporary and frequent access? I already answered that one. Designated areas, what are those? It's not a painted line. I see painted lines all the time. I don't understand how they became so popular. They've never been allowed as fall protection in general industry, in construction, in the old code and the new code. OSHA has explicitly come out and said that they're not considered fall protection because you get snow, they disappear. You get equipment on your roof, they disappear. You have to have a physical barrier 39 inches tall with sag no less than 34 inches, visible from 20 feet. OSHA could not be more clear. I don't understand why they're so popular. As far as solutions that we provide, non-penetrating rooftop guardrail on the edge. And again, that's what we do the most of. So we don't want to poke holes in your roof, cause leaks, void roof warranties, but we still maintain OSHA compliance. Or we'll do a non-penetrating warning line system that meets those requirements or those regulations without voiding any of your roof warranty. And then here is our last concept. So, about 2 minutes will be done. So if you have any questions, throw them in there. I'm hoping to have about 7 minutes left for questions. This is the last concept I want to leave everybody with. And this is called the hierarchy of fall protection. We adapted this from the hierarchy of controls. If anybody you are familiar with that concept. The idea here is that we're trying to reduce risk. So the best solution is higher up on the hierarchy. And the way that we say something's the best is that it reduces the most risk to the building owner and the user. The lower we go on the hierarchy, the more risk we're assuming as the user and the owner. And then we took it and we applied these concepts to a real life example of skylight fall protection, which have an unprotected skylight. How do we implement these solutions? So any fall hazard, what's the best solution? Eliminate the fall hazard, right? It's almost too obvious to think of. So if I apply that idea, that concept to skylight fall protection, the way that it looks is that we remove the skylight. So we're doing a re-roof, remove the skylight completely, put in LED lights, and we get rid of it. Now, might not be practical, right? I like lead points on our projects. I like the natural sunlight, but that's an example of a way to eliminate a fall hazard completely because you can't fall through a skylight that doesn't exist. It's that simple. If that's not practical, but we have the thought exercise, we think, how do we eliminate this hazard? If it's not possible, we go down one rung. So then we're into a collective fall protection. Collective meaning it protects everybody on the roof. I can have 2 or 20 people on the roof. It's going to do its job. We call it passive because it sits there no matter what you do, and it will protect you no matter what. Typical solution would be a guardrail around the opening or a cover over the skylight. I have 2 people, 3 people, 10 people on the roof. That guardrail is going to do its job. That barrier will do its job, keeping people from falling through the opening. And they don't need to wear any PPE. They don't need to be tied off. Next, let's say, cost is an issue. These tend to be more expensive solutions. So we go one rung down. We say, okay, we want to go into what's called active or personal fall protection. Now PPE is involved. When PPE is involved, we have what's called the human factor. We are being required to wear our PPE. It's inconvenient. It's hard to police. Every facility that I walk through, the safety manager, put your hard hat on, put your safety glasses on, tie out to that lift, right? That's all I hear as we're walking through. The roof is kind of out of sight, out of mind. So adherence to the rules is really bad in rooftop fall protection. But we could integrate a work restraint system. So if you are tied off properly, we've eliminated the possibility of a fall because it's a restraint system. If that's not practical, then we go to our last resort, which is designing a fall arrest system. Fall arrest means that I'm going to fall. I'm going to be tied off. Now, earlier I described, right, the fall distance required, 12 to 15 feet, 17 feet if you have a horizontal lifeline. off the side of a building and the different factors that could reduce that fall distance. So that's a risk that we need to consider. The other risk that we need to consider is what's our rescue plan? When somebody falls off the side of a building, they land in their harness, they take maximum arresting force is 900 pounds. If you're wearing a 6-foot free fall harness, or 1,800 pounds if you're wearing a 12-foot free fall harness. So you have a huge amount of force that hits that person's body. So they've probably gotten whiplash from the fall. They've hit the side of the building. They may be knocked out, and they have a huge amount of pressure on their legs where their major arteries are coming in. So you have to have a rescue plan to get them down in less than 15 minutes, or we're going to have suspension trauma. So we have a whole set of issues when I have a fall arrest system that I need to consider. And surprisingly, this tends to be where everybody's mind is at when I meet them. When they know they have a need, they're like, yeah, let's just put some anchor points in. And then we get into the design requirements, we get into the implications of the fall, and we try and work our way up. Well, can we get away from arrest and make it restraint? Can we get away from restraint and make it collective? Or can we eliminate the hazard completely? And that's our goal. That is the safest solution when it comes to rooftop fall protection. 4 minutes left. I'll give it back to Barry. But if you'd like us to come out, assess your roof for free, provide you with solutions, we have 24 reps all across the US that are experts that want to come look at your facility, partner with you in this. Come to our website, reach out to us. We'd love to help. Any questions I can answer, Barry?
Daniel, thanks so much for sharing your insights with us today. We appreciate your passion for this topic. Before we start the Q&A, I want to let everyone know about the evaluation survey that we're asking you to complete. The survey will open in a different screen after this webinar, and your input is important to us because it does help to improve our future webcasts. Now let's get to some of those questions. We had a couple questions come in, Daniel, regarding edges, and thank you, Steve and Stacy, for the questions. I'm going to kind of piece them together here. Does OSHA still maintain that there is no safe distance away from a leading edge when working on a roof? And if not, what is considered a safe distance from the edge for general industry work where fall protection is required?
That is such a good question because it pinpoints the difference between the original OSHA code and the new OSHA code. The original 1910-23 OSHA code stated for leading edge, any edge 4 feet or more above a lower level must be protected by a full perimeter guardrail. And that was it. Then there was letters of interpretation. Hey, what if I'm 50 feet, 100 feet away from the edge? Do I still need to be protected? And OSHA said, we don't consider distance from the edge as a factor in fall protection. And that's kind of crazy because I'm 50 feet away. Like, I feel pretty confident. And so in the code, what OSHA is saying is that the safe working distance away from the edge is 15 feet or more for temporary and infrequent work. So if I'm 15 feet or more away from the roof edge and my work is temporary and infrequent, that's what they consider safe working distance. I'm there all the time, I don't have, it's not infrequent work and it's not temporary work, then that exemption doesn't apply, but I can officially use a warning line system instead of a guardrail where they just said full perimeter guardrail. And then we would try and get a warning line in as a non-conforming guardrail, which would get written up as a de minimis violation. So they've kind of simplified it. So that's a really good question because it shows a very in-depth understanding of the original code and interpretations and what they tried to kind of simplify by coming up with kind of the zone approach with the 0 to 15 foot breakdown.
Great. Thank you for that, Daniel. Rick has a situation that he wants your thoughts on. He said, I had a warning line at 15 feet and a no entry without fall protection and roof anchors at 15 feet. We had no units within 15 feet, so there was no reason to be closer than 15 feet. Was that wrong?
No, I mean, because we don't know what's going inside of the 15 feet, right? So that warning line is to protect people from going within that, we call it the danger zone, right? Within 15 feet of the roof edge. If I'm doing, like I just said in the last one, if I'm doing work that is not temporary and not infrequent, um, within that 15-foot zone, the warning line is required. The anchor points would be what you would use if you were to go outside of that zone. Who knows what you're going to need in the future when it comes to roof repairs. So you're prepared to take care of, as needed, the anchor points at 15 feet. So it's not wrong. It's actually a really good plan because you're protecting the people inside that 15-foot area. And then you're prepared for any as needed maintenance for roof leaks, drains, whatever it is, receiving equipment, loading equipment to fix units within inside the 15-foot zone with those anchor points. So it's actually a really good solution.
Great. We thank Rick for sharing that. Uh, Daniel, looks like we have time for one more question today, and that's going to come from Brock in our audience. And Brock asks, does OSHA require all of the ABCs of fall protection to be from the same manufacturer?
No, that is not a requirement. You can kind of pick which manufacturer that you want to use. But here's the nuance, or I guess my suggestion. When supplying an anchor point or horizontal lifeline, we work with trained integrators. They typically install nothing but fall protection. They have PEs on staff that are meet the competent person requirements to design fall protection equipment. They're trained on installing and recertifying your equipment. They do the annual inspection, which is required by every single manufacturer of a lifeline system. They'll do your training on site after it's been installed, and they'll do your 5-year anchor testing that's required by ANSI. So the person you want to be loyal to is not the manufacturer, it's the integrator. The person who's installing that, inspecting it, and training you. They'll provide the PPE that you need and give you that the professional service so that you're covered. So we partner with a network of partners all over the US of fall protection professional integrators who should take care of that for you.
Great. We appreciate the insight on that, Daniel. Folks, unfortunately, we've run out of time today. We thank you all for attending, and we'd appreciate you taking just a minute or two to share your feedback via our survey. A big thank you goes out today to our awesome presenter Daniel Huntington, and of course, everyone from our sponsor at Kee Safety. This ends today's Safety and Health Magazine webcast. Take care, everyone, and have a safe day.
Thank you.